Up until this point in your math journey, you have already done a considerable amount of work with exponents. However, have you ever taken a moment to consider what happens when the exponent becomes negative? Well, in this section, we're going to learn exactly what happens. But before doing that, let's start by doing an investigation. So we know that an exponent means taking the base and multiplying it by itself as many times as the exponent indicates. Additionally, we understand that the opposite of a positive number is simply that same number, but negative. So what do we think will happen when we encounter a negative exponent using that logical reasoning? So I encourage you to pause the video and just think through potentially what you think 3 to the negative 2 power might be. And assuming you've given it some thought, let's go through this. So, right, we know that exponent means multiplication and that the opposite of a positive number is a negative number. So using that same logic, if we want to find the opposite of 3 squared, negative exponents, that means that we're going to do division. So negative 3 squared is 1 over 3 squared. And then if you want to simplify this, we know 3 squared is 9, so this equals 1/9. So 3 to the negative 2 power equals 1/9, actually. And if you think about it, we know that 3 squared, like if you're just asked to evaluate 3 squared, we know that's 9, right? So if we take 9 and multiply it by 3 to the negative 2 power, we know that here we're seeing that was 1/9. So this ends up becoming 9 times 1/9, which these 9s end up canceling, and you just get 1. So negative exponents undo positive exponents. Well, not quite, but that's the idea, is that negative exponents have the inverse operation, so we're going, negative exponents means we divide. Positive exponents means we multiply. So here's the following general rule for negative exponents. So if we have x raised to the negative a power, that just equals 1 over x raised to the positive a power. And that's it. So with that in mind, let's dive into the following examples. But one thing I do want to note before we go into these examples, in math, you never want to leave an answer with a negative exponent unless you are specifically asked to do so. And then also, recall this following rule. So whenever you have a whole fraction raised to some power, that power gets distributed to the a and the b. So we get a raised to the x power divided by b to the x power. So for example, number 1, we have x raised to the negative 2 power. So using the exponent rule we discovered on the first page, this just becomes 1 over x squared. And that's it. That's your answer. Looking at example number 2, we have 4 times x all raised to the negative 1 power. So since this whole thing is being raised to the negative 1 power, we're going to have to distribute in that negative 1 to that 4 and the x. So this becomes 4 raised to the negative 1 power times x raised to the negative 1 power. Well, 4 to the negative 1 power, that just becomes 1/4 raised to the 1 power. And then we're going to multiply that by x to the negative 1 power, which is 1 over x to the 1 power. To the first power, my apologies. To the first power. Well, anything raised to the first power is just itself. So our final answer is 1 over 4 times x. And that's your final answer. Alrighty, so for example 3, pause the video and try this example on your own before we go through it together. And assuming you've given it a go, let's go through it. So we have 4 times x to the negative 1 power. Well, this 4 is just being multiplied by x to the negative 1, so that just comes out in the front. We're not going to do anything with that 4. But that 4 is being multiplied by x to the negative 1 power. And we know that x to the negative 1 power becomes 1 over x. And then 4 times 1 over x just simplifies to 4 over x. So that's your final answer. Looking at example 4, we have 1 over x to the negative 5 power, or the negative 5th power. So how might we go about this one? Because we have a negative exponent in the denominator now, and not in the numerator, like we've seen before. Well, if we want to make this exponent positive, all we have to do is bring that up to the numerator. So we have x to the 5th over 1. And then anything divided by 1 is just itself. So our final answer is just x to the 5th. Looking at example number 5, we have x over 2y all raised to the negative 1 power. So to evaluate this, I'm going to take that negative 1 and distribute that power to both the x and the 2y. So this looks like we have x raised to the negative 1st power all over 2 to the negative 1 power times y to the negative 1 power. Well, in the numerator, we have x to the negative 1. So to make this exponent positive, I'm going to bring the x down to the denominator. So we get x to the 1st power. And then to make exponents positive in the denominator here, 2 to the negative 1 power times y to the negative 1 power, I'm just going to simply bring it up to the numerator. So we get 2 to the 1 power times y to the 1 power. Well, as we've seen, anything to the 1 power just equals itself. So we just get 2y over x. And that's your final answer. Alrighty. And for the final example in this section, I encourage you to pause the video and give this a go. And assuming you've worked through this example, let's go through this. So we have 3 times z to the negative 4th power all over 7y all raised to the negative 2 power. So how are we going to go about this? Well, the first thing is to recognize that we can distribute in this negative 2 to both the y and that 7. So we're going to get 3 times z to the negative 4th power all over 7 raised to the negative 2nd power times y raised to the negative 2nd power. Now that we've distributed in that negative 2, our next step is to make our exponents positive by using our rules that we've learned. So to make this, this negative 4 a positive exponent, I'm going to bring that down to the denominator. So we're going to have z to the 4th. But this 3 here doesn't have an exponent attached to it. So I'm just going to carry that along in the numerator. And then the denominator here, we have negative exponents. We have 7 raised to the negative 2 power and y to the negative 2 power. So I'm going to bring both of these up here in the numerator. So this becomes 3 times 7 squared times y squared. And now we can do a little bit of simplification because we know 7 squared evaluates to 49. So we're going to get 3 times 49 times y squared all over z squared. And now we can multiply that 3 by 49, which ends up becoming 147 times y squared. I'm just going to say 147y squared all over z to the 4th power. And that's your final answer.